Hello, everyone. Welcome to this third session in what I think is a very interesting conference. So in this session, we have 4 papers again, all 4 showing how job vacancy data can be used in research. So we have speakers from University of Warwick, the Institute for Employment Studies, Burning Glass, and University of Oxford. So as with previous sessions, this session is being recorded. If you have questions, please put your questions in the Q&A, and please do so as the session is going along. And in your question, please say who the question is addressed to. So without further ado, we'll move over to Jeisson, who's presenting on developing online job vacancy data for labour market information for all, from the Institute of Employment Research at Warwick.
Thank you very much, Mary. I'm just going to do a short introduction before I hand over to my colleague, Jeisson Cárdenas. Jeisson is leading on the web scraping work at the Institute for Employment Research. So we go to the next slide, please. Thank you. So the web scraping data that we're producing is part of the LMI for All project. LMI for All has been running since 2012. It was given full project status in 2015 after the development phase and the piloting. It's currently funded by the Department for Education. LMI for All is a freely accessible service. It's a database where we bring together national sources of high quality labour market information. And we enable access to that data through an application programming interface. And then career service providers, particular websites, use that data and visualize that data alongside other data. And it's mainly aimed at supporting the work of careers professionals. So you'll see our data used in, for example, the ESCoE website, the EXplore Start programme, the National Careers Service, and the BBC Bite Size Careers. So the web scraping work that we're doing is currently being piloted. There's 2 strands to this work. So we are releasing on a monthly basis the web scraping data through LMI for All and the API. And we're also doing some work with the skills advisory panels to do some local level data analysis on the vacancies. I'm going to hand over to Jeisson now, who will talk you through the data set and the methodology.
Thank you very much for this space. Next slide, please. Well, basically, this is an example of LMI for All, how it works. Basically, what I want to show you here is that the LMI for All combines different sources of information. So the idea behind the web scraping and the analysis of the database is to combine the data with the ONS data or with other official sources of information that we have available here in the UK. And next slide, please. So as Sally had mentioned, we are currently scraping 4 job portals. As I was going to mention after, we are a really relatively small institute, so we are not specialized in web scraping or these data science techniques. But although we think that with a really good sample of job portals online, we can get powerful insights about the labor market. That's why so far we have selected these 4 job portals. In the next slides, I will tell you why we select these 4. But basically, the aim is to update this information at least every month to the public. But of course, we are scraping the data on a daily basis. Next slide, please. So basically here is just an overview of the process that we are conducting to scrape the data. Basically, we have selected the main job portals, or the ones that we consider the main job portals for this project. Basically, we based our selection process in three characteristics of the job portals. The first one is the volume of information. So we consider those job portals that have a considerable number of observations, your vacancies. The second criteria is the quality of the job portal. Basically, by quality, we refer to basically if the information in a certain job portal has certain minimum labels. Sometimes the information in some job portals are a little bit disorganized, messy, and this characteristic is quite important when we try to process the data. And the final one is the number of visits or the data traffic for each website, just to be sure that we are taking into account those job portals that are the most famous one in the UK. With this criteria, as I mentioned, we have selected 4 job portals. After the selection process, of course, we code our scraping and we start scraping the data. After we scrape the data, which is a process that it takes every day to download each the databases, we conduct a cleaning and coding process, and this is the main point here, which is our aim is to have a vacancy database that we could compare with official sources of information from the ONS or from other sources. So here is where we spend a little bit more of time, for instance, trying to code job titles into occupations, or coding the company's names into SIG codes. And after that, we upload the data and we basically connect the data with other sources of information. Next slide, please. So basically, just to give you an overview of the variables that we have constructed so far, we have in this database the job title, which comes from the job portal. The job title, I think, is one of the most important variables because it gives you the opportunity to know the occupation, and the occupation is linked to skills information and tasks information. So what we are doing is coding these job titles into SOAK to 4-digit level. This is quite important because what we want to know, to compare is the job vacancy data with, for instance, the ONS data from the labor supply surveys. Here it's quite important to point out that there are a lot of methodologies to do that. For instance, machine learning, text mining, and among others. We think that there is not an only unique methodology that can code all the job titles in the vacancy database. Actually, what we have seen is that the best way to do it is following a mix of methodologies. For instance, just to give you an example, we implement Cascode, which is a software developed by University of Warwick to code job titles. We run machine learning models, and also we run text mining techniques, other text mining techniques to code job titles into occupations. Well, basically, other variables that are really important are the location, with the input that we have the location variable that from the job portals. we are coding the counties and the LAPs of each vacancy. It's not an easy task because employers uses different languages, different ways to mention, for instance, a place in London. But this to do that is necessary to apply other different methods. Also, we have mapped ESCoE skills into the vacancy data. And I think this is one of the most important things because the data, vacancy data, allow us to identify some patterns in the job description. However, I think we need to have a little bit more discussion about what it means when an employer posts a specific skill, which is, it means that it's the minimum requirement, or is the skills that they don't find in the job market, or basically it's just a normal way that they don't pay attention too much on the skills that they mentioned, and you just put a list of skills that they think that it might be.
You've only 1 minute left.
Okay. Next slide. So basically here there are some results. Basically, I want to point out that the data is consistent, although we don't scrape all the vacancies. We have a really high volume of information. The data is consistent. Specifically, we can see it here in the period of the COVID-19. Next slide, please. Here is a really important slide. This is basically a trend by occupational groups. We have seen that the time series is consistent over time. Next slide, please. And well, basically, this is just statistics of the data. But I want to show you, next slide, please. And the other one, please. Next ones. Okay. This slide. This is the last slide that I want to show you that I think I consider the most important one of the most important ones. Basically, we have compared our job vacancy data from the UK with other countries' data. And we have seen that the data has, it provides us like logical results. More advanced countries concentrate more vacancies in professionals and technicians occupations, while less advanced countries, this is 2 Latin American countries, but we also have more countries, it tends to have a higher participation of lower skills occupations in the data vacancy days, which is basically reflects the structure of the labor market in each of the economies. I think I will just stop here, and thank you very much for this space.
Okay. Thank you, Jeisson. Okay, our next paper is giver is Dafni, monitoring the effects of the COVID-19 panic on the labour market. So over to you, Dafni. Again, 10 minutes, please.
Thank you very much. Hello, everybody. My name is Dafni. I'm a researcher economist at the Institute for Employment Studies, and thank you for having me here today. I will present our work that was funded by the Joseph Rowntree Foundation that led to a series of briefs, weekly first and then monthly briefs, monitoring the effect of the pandemic on the labor market using vacancy data that started in April 2020 and ended in October. And next slide, please. Great. So we know that the pandemic and the policy measures that were taken to limit the spread of the virus had a profound effect on the labor market. And in order for us to be able to address the challenges of this pandemic, we need timely and rich information that can help us form targeted policy responses. However, there are some limitations in the traditional data sources at the moment. First of all, there are time delays. So there are time delays between the period of time that the data refers to and when we get access to them. And there is some lack of granularity as well in terms of geographies, industries of jobs and occupations. Next slide, please. For this work, we use the Adjuna vacancy data. The Adjuna is one of the largest online job search engines in the UK. It aggregates job ads from different sources. It covers at least 90% of vacancy activity. And for this project, they gave us a weekly real-time census of data, an extract that we got every Sunday during the period. And the information we got for the vacancies were on the date that the vacancy was created, the job title and the full description, the location, that was a longitude and latitude point that was given to us by Adjuna. They used an algorithm to map the raw location variable to this point. Job types, those are 27 broad occupational types created by Adjuna. Predicted salary, that is created by their function Jobsworth, whether the contract was temporary or permanent, or part-time or full-time, and information on the companies. Next slide, please. We use the date of the advertisement to create an index of job flows and job stocks. So the job flows were jobs that advertised for less than 7 days, given the fact that we had a weekly extract of the data, and job stocks were jobs that advertised for longer than a week. We could also calculate the length of time a job ad was being advertised for. And of course, there are always limitations when you use this information, given that a job might enter the site and then re-enter again and again for different reasons, or maybe there's an ongoing recruitment for a role. Next slide, please. So it is very important to have information on job flows because apart from job stocks that give a very good picture of the market, job flows can give us a better understanding of the dynamics. So we have a completely different picture when we have low job stocks and low job flows, and when we have low job stocks and high job flows. Next slide, please. When it comes to geographic granularity, we took the longitude and latitude points and used the package postcode IOR to match those points to local authorities. We also did some manual checks to correct for some English local authorities where the matching did not agree to the raw location data. And then that allowed us to not only analyze data by government office regions and devolved nations, but also by different groupings, taking into consideration the local authority characteristics, such as the local enterprise partnerships and honest typologies. Of course, again, there's a limitation here because there is a loss of accuracy the smaller the geographic area that you focus on is, but there are also benefits to it. So next slide, please. So looking at location groups that share similar characteristics, for example, here I will talk about honest typologies, it helps us understand better how different types of areas were affected by the crisis, given their local economy characteristics and their history many times. So, for example, the remoter coastal living, so coastal areas versus the rest of the areas, has a very interesting story to say. And what is also important is that when we focus on local small geographies, we can combine this with other local information, such as the population size, and understand things like vacancies per capita. Next slide, please. So for this example, as I said, I'm going to show the coastal areas versus all the other types of areas. So here we look at stocks in 2019 and 2020 for both types of areas. Those vacancies have been indexed using as a base the 4th week of February. And we can see here that the crisis affected both coastal areas and other areas a lot. However, the decline was much sharper in other areas than it was in coastal areas. However, we know that coastal areas are much poorer on average. So next slide, please. So here we are looking at the vacancies per 100 people of working age, and we can see that even before the crisis started, that the vacancies per 100 people of working age were much lower, almost by one whole vacancy in coastal areas than they were in other areas. Next slide, please. So to understand better why different areas have been affected to a different extent, we need to focus also on the type of the economies, the local economies in those areas. So for example, we know that the industries that were least affected by the current crisis were healthcare, nursing, and social work. However, at the same time, those industries and maybe some others may have lower remuneration levels, which might have something to say about the quality of jobs advertised. So understanding the type of industries that predominate in different types of areas gives us a better understanding of how the crisis is expected to affect different areas and why it has. Next slide, please. So here, for example, we're looking at the top 10 most advertised jobs in coastal areas and other honest typologies. And we see that 16 to 18% of advertised jobs in coastal areas are in healthcare and nursing, and 6 to 8% of them are in social work, whereas in other areas, less than 4% of jobs are in social work, and 8 to 10% are in healthcare and nursing. Next slide, please. However, even though in coastal remoter areas, the predominant industries are the ones that were hit the least by the crisis due to its specific nature, we see that the pay in those advertised jobs is quite low. So 75% of healthcare and nursing jobs pay less than 35K, and the same holds for social work, where less than 75% of the advertised jobs pay less than 25K. On the other hand, 70%, about 70% of IT jobs that are the predominant advertised jobs in other areas pay more than 35K. Next slide, please. As I said, the fact that we can focus on small geographies allows us to combine the number of vacancies with other measures of those areas, such as the unemployment levels. Now, combining the number of vacancies and employment levels can give us information on the labor market tightness, which is very important, especially during a recession. So we also use the number of vacancies and the claimant count by local authority to see how the crisis affected areas differently. Next slide, please. So here again, as an example, I'm showing you the number of unemployed claimants per vacancy by ONS typology. So we can see here how outer London and other metropolitan areas, as well as old industrial legacy areas, were the ones that were affected the most by the crisis when it comes to not only fewer vacancies advertised, but higher unemployment levels as well. Next slide, please. And here we look at the same, but this time by local authority. Those two maps have darker colors to represent higher claimant vacancy ratios. And we can see that inner city and ex-industrial coastal areas were faring the worst. And also central districts of cities which had relatively low ratios were better off than their surrounding areas. Next slide, please. So
1 minute, please.
Great, thank you. So all in all, unlike survey or administrative data, the quality of information that each advertisement has, it depends on the person uploading the ad. So that means that information on occupational group, predicted pay, type of contract, or anything else is really dependent on the person uploading the ad. So we need a consistent approach to clean and retrieve information. So as we repeat this analysis over time, it is properly comparable. Next slide, please. Here is an example of matching vacancies as we match them with occupations that shows that there was a higher decline in administrative and secretarial occupations and smaller in caring and leisure services. Next slide, please. So all in all, it is very important to use vacancy data as it gives us timely information, and geographic granularity is very important, especially for policy responses. Currently, what we need it's not available at the moment is more information on job flows. And finally, it is very important that everybody who works on Vacancy has an open communication, because we need to develop systematic approaches so that we can retrieve good quality information and robust conclusions. Thank you.
Thank you, Dafni. So our next paper is from Bledi from Burning Glass, and Bledi is joining us from Boston. So it's over to you, Bledi.
Good morning, everyone from lovely Boston. My name is Bledi Taska. I'm a chief economist at Burning Glass Technologies. So today I'm going to talk to you about how we can use online job postings data to understand the labor market trends and job opportunities in the United Kingdom. This is joint work with our partners, RCT and Guilds. Next slide, please. This is a summary of the presentation. I'll try to make it quick. In terms of motivation, I think this audience doesn't really need one. But again, just showing a little bit of the problem, I'm sure others have shown as well, but we're going to spend a little bit more time in the framework, and most importantly on the concept of skill adjacency and how is it useful in this case and how is it different. And then we're going to show you how we are defining and how we are measuring at-risk, lifeboat, and target occupations. And finally, we're going to discuss some regional analysis we've done and show why this is important, especially for policy implication. Next slide, please. So in terms of the problem, I think everyone understands that the labor market is not doing that great. This is not only in UK, across the world, but in UK as well. Unemployment rate is significantly higher than what it was last year. And this is actually also hiding the fact that youth unemployment is significantly higher. But redundancy rates is almost at historical level. And this is, I think, very, very well understood by now, and this part of the problem. Next slide, please. But hiring rates have also shown very similar patterns. So this is our data that shows weekly changes. Hiring's plummeted during the first couple of weeks, I think, of the pandemic. I'm sure this is not a surprise. I'm sure other people have shown very similar pictures. And essentially, they did a little bit better during the summer, but now we're following a second wave. Next slide, please. Next one. And essentially, this is sort of part of the problem, and this is one of the main reasons why we're all here. But what we were tasked in this report and in this project was like, what can we do about solving that problem? And we know that there are a lot of jobs, and we know that there are a lot of people that are getting other jobs. But we know that there's a lot of employers that are still hiring. So our task is here is that can we use this information that we know from online job postings about the sort of the DNA of the jobs and how those jobs overlap with each other to suggest pathways about the next job. And this is our definition about lifeboat jobs. What can be the best next job? But not only that, we didn't only want people to go in a job, we also wanted to think about long-term career mobility. And for that reason, we also wanted to see what are target occupations that they both overlap, but they are offering good career mobility. And there was two reasons for that. I mean, the first reason is that from an economic sense, that is the right thing to do. What you don't want to do is move people to a next job, but that is sort of a dead-end job. But at the same time, by providing people with information that not only this job is, it is available, but there is career mobility, you would motivate them more to make the transition. Next slide, please. Right. And in terms of the framework that we're using here, there's a very simple but very powerful concept, and that is of the skill adjacencies, right? And essentially, the difference between skill adjacencies is that usually when people have done career pathways in the past, or like if you think about how we usually make decision about what jobs to make, we see what other people have done, or we analyze panel data and we see what our colleagues have done or what information we have, right? And that is based on sort of this is the concept of realized pathways. But in a current situation where things are changing significantly and there's a large shock, and there are cases where this shock is in the whole industry, that type of analysis and that type of method is not very useful. So think about the hospitality industry, for example, and in that case, if you are thinking about making career transition in the hospitality industry, that is not possible. So this is where the skill adjacency concept is very helpful, because it allows you to think outside of the box in ways that can I make a transition essentially that it does make sense and it is possible, but might not necessarily be common. And again, this is a method that has been by now in several reports. We've used it first in the Reskilling Evolution reports for the World Economic Forum and BCG, and it's been adapted by several recent reports from the Australian government, Federal Reserve Bank in Philadelphia, and a very recent report by NEST. Next slide, please. And I'm going to make this example quick, but I think this is a nice, a fun one because it comes from a personal experience, but I think a lot of you can also identify it. Think about the role of economists in tech, right? If you go 10 years ago, not a lot of economists were going in tech, and actually economists were following very traditional pathways. They were going to banks, they were going to a large organization, consulting companies, and academia. So essentially, this was a very linear pathway. So if someone in 2014 or 15 was thinking about what should I do in my career, right? And if they look data from the supply side or even from the demand side, their decision would have been very linear. They would do what other people had done. But essentially, if you look at the commonality between sort of like what an economist is doing in tech and in data science, these two jobs are fairly similar in terms of the task. But in terms of what people have done, or in terms of the job titles, they don't seem very similar. And then, we've seen this evolution where sort of the role of an economist and data has transformed into data science a lot in the tech world. Go to the next slide, please. So essentially, we did three things here. First is we wanted to identify at a very granular level the risk occupation, and this is where online job postings, as Dafni said before, are very helpful because they can give you at a timely manner very granular information. Next slide, please. And this is sort of the results that we find if we do a year-over-year analysis. Again, not very surprising, the majority of these occupations are either in hospitality industry or they require very close contact to other people, essentially, to do jobs. But I think, the added value here is that we can go very granular in terms of the occupation and at a very timely manner. Next slide, please. And what we were tasked here was that how can we move these people to sort of next step occupation and to other priority sectors. We are given some specific priority sectors in this project, but again, this type of task can be done for any priority sector that the policymaker has in mind, but it can also be done also for the economy as a whole. Next slide, please. So essentially, there were three main things that we were looking when we thought about this sort of blackboard occupation. The first, obviously, we wanted them to be similar in terms of skill. We wanted them to have salary differential, but not significant, either in a positive or negative side. I don't want to spend too much time because this is a very nuanced, but essentially, the salary difference is very important to make sure that, these transitions are actually feasible. And then we wanted not to have large barriers to entry. So you didn't want the education level of the starting job and the next job to be significantly different in terms of education, so you don't need significant training. Next slide, please. And you can see a lot of examples of the transitions in the slides that we would share afterwards, but also in the report that is coming in January. I think the one that makes the point more clearly is the bartender to pharmacy technician. If somebody sees this, or if somebody looks at what bartenders do in their career, leaving aside the people that they're just doing this as a side job and then they're studying, is that most of them they move within the industry that they're in hospitality, and they move upwards. But again, as I said, in this current situation, that is not possible. The whole hospitality industry has had a shock, so that move is not possible. So if you think about, or you ask a bartender, the first thing that they want to think about is not becoming a pharmacy technician. But if you look at the component, the skill, DNA of the two jobs, they are very similar. A lot of the skills that a bartender is using in the day-to-day are the skills that a pharmacy technician is doing. From the job titles, they don't look alike, but from the skills, they are very, very similar. These are the middle skills. Obviously, you'll have to learn some things, but this is not a hard-to-entry job. You don't require certification, or you don't even, you don't require a license to become a pharmacy technician in UK. Pharmacy technician, obviously, as you can understand, is a job that is increasing significantly right now, and bartender is going down. So this is sort of like one of those transitions that make this point very straightforward. Next slide, please. Next one. Right. And this was the first part, was sort of like, how can we identify the next step jobs? But we also wanted to identify target occupation. And again, these were occupations that were overlapping with the livable jobs, but they were also good, career opportunity occupations. So they were growing, and they were growing either before COVID or during COVID. And also you wanted to move people to jobs, not that they are very small and niche, but that there is significantly higher demand for this job. Next slide, please. So this is some of the examples of the transition from light boat to target occupation. Next slide, please. And I think here is where it comes that, for example, the importance of using information on the growth of this occupation both before and after. The blue is during COVID and the orange is before. The two examples that are fairly different is data science, for example, and sales delivery driver. Sales delivery driver was decreasing as an occupation before, but again, with e-commerce and everything is going up, so this is a good opportunity. And on the other side, data scientist is not one of the occupations that is growing the most, during COVID. Not a lot of, I think it has decreased a bit, but we do think that this is going to be an occupation that is going to bounce up pretty fast afterwards. Next slide, please. So regional analysis is very important also for this type of research, and also for, most importantly, for policy implication, because you can identify jobs that are close to each other, but they're not necessarily are in the same location. And so I think we have not explicitly done this in the analysis, but it is very implicit in terms of like we do go and see where these jobs are. And if you go to the next slide, please. This is a heat map of location quotients that they show the concentration of where these jobs are. And wherever you see about one or a lot of blues, that is where there's high concentration specific jobs. And obviously, you can imagine, that a lot of the business and IT jobs, data science, data engineers are in London. Seems like there's a lot of economists in Northern Ireland, and in Scotland and Wales, you do have a lot of blue-collar jobs or healthcare-related jobs. Next slide, please.
1 minute, please.
And this is another way to see the same information. Again, if you do it by map and you map the location quotient and the concentration, you see, for example, data scientists being very heavily concentrated in London, but vice versa, some of the mechatronics engineers, they're more concentrated in Northern Ireland or East England. And next slide, please. So I think, to summarize, one of the things that we wanted to show is that, job posting, online job posting can provide insight into best short-term employment opportunities, but also opportunities in the future. But I think the most important point that we wanted to do with this report is to show that you can and you should use a data-driven approach that relies on skill adjacencies, because this allows policymakers to reskill workers in the most efficient way. That way that they capitalize not on moving people to something completely different, but actually capitalizing on pre-existing skills of the unemployed workers. Thank you.
Thank you, Bledi. So we'll now move on quickly to our final paper on flexible work arrangements. So over to you, Matthias.
Thanks for the introduction, Mari. So in this paper, we study flexible work arrangements in low-wage jobs. The research is supported by a grant from UKRI as part of a research project on English law and AI. And it also uses burning glass data, so it's the same data set that Bledi has showcased previously. Next slide, please. Oh, sorry. The work is jointly with Abby Adams from Oxford University, with Maria Balgova from the University of Bonn, and with Tom Waters from the IFS. So to motivate this challenge on schedule flexibility, point to the movie Sorry We Missed You, which is a very good depiction of the stress and the burden that schedule flexibility puts on workers at the low end of the distribution who can't afford to get sick, to miss a meeting at the school, to lose the tracking device that the delivery drivers use when they deliver the parcels. And from seeing the challenges, one of the questions then is how prevalent is the schedule flexibility at the low end of the wage distribution. Next slide, please. So we distinguish between two types of schedule flexible jobs. The first type is kind of the good type of schedule flexibility, where you know ex ante before the month starts how much you will have as income, and where you then choose to work the hours necessary to perform the job. So you can think of a professor as having this type of a good schedule flexible job, and we call this a salaried schedule flexible job. The low quality schedule flexible job is a non-salaried schedule flexible job where you do not know ex ante before the end of the month what your earnings will be for performing this job. So both your income and your hours are unknown to you prior to the month. Next slide, please. There's ample literature on flexible work arrangements, zero-hour contracts. One of the related papers is from Data AI 2019, who look at social care workers. Then there are special surveys that look at this question, but unfortunately they aren't repeated, so we don't have panel data. And Abby Adams has been running with colleagues a COVID-19 survey that tracks the hours of workers during COVID-19. And of course, there's also, as this conference showcases, ample literature on the use of online job vacancy data. Some of the leaders in this area are Lisa Kahn, and she has Herbstein and Kahn as a paper, Deming and Kahn as a paper. Bledi, who was presented previously, also has a range of very interesting papers using this data set. And just to highlight some others, there's a paper by Jakovic, who's the chief economist of the EBRD, who looks at the shock of Brexit, of how that affects the labor market. Then next slide, please. The 4 key takeaways from my call. So if you leave this call, I hope you remember four key takeaways. The first key takeaway is that as we're working with large corpuses of text, from Berlin Glasses and terabytes of job vacancies, machine learning, specifically natural language processing, can be very important to improve our measures that we derive from the job ads. Second key takeaway is that with our new machine learning derived measures for schedule flexibility, we can point to a strong rise in their prevalence since 2014 when our data series started. Then we look at the reasons of why this is happening, and we think it's a trade-off between, or like employers want to reduce labor costs and offering low schedule flexible jobs where you only pay the worker when he's working is one of the ways to reduce the total wage bill. And then finally, we look at COVID-19, and during the spring lockdown, we find a temporary surge in schedule flexibility in the UK. Next slide, please. So on the first point, that machine learning improves the measurement of schedule flexibility in job ads. We have a pipeline, next slide, please. We have a pipeline that we follow to do the natural language processing, and it has 4 steps. And in the interest of time, I'll only kind of point out what the 4 steps are. The first step is to pick a database of choice for your labor market data. We were very fortunate to work with Burning Glass. We're big fans of the data set, and that it's very well structured. It's huge. For the UK, it's 50 million vacancies that we use, and that they come from 7,500 job boards and company web pages that are monitored by Burning Glass. Then as a second step on the next slide, we'll highlight that we do a very intense labeling exercise. So we have read 6,500 vacancies multiple times because multiple people have read them. And we manually flag the vacancies regarding if they relate to schedule flexibility as a contract type or not. Then in the next step, after we've labeled the data, there are different ways of representing text data as numbers. So that's what you ultimately have to do, because supervised machine learning algorithms only work with vectors and numbers. And here in this paper, we've tried all of them. And the one that tends to work really well is the simplest of all of them, which is to use the binary count vectorizer, which represents if a word appears, which is in the vocabulary, in the job ad, you put a 1. If it doesn't appear, you put a 0. It's as simple as this. And we use this as input matrix into the machine learning algorithm. We use another very simple algorithm called the logistic classification model, and then are able to derive substantial improvements on the performance to keywords. So if we could move forward in the slides. Move forward. So these were just example job ads that related with schedule flexibility. And we benchmark our machine learning model to a keywords-based model, where we use the keywords that the machine learning algorithm highlights But the benefit of using the logistic regression model is it not only has positive keywords, it has negative keywords. And by using both kind of the words that indicate that the flag is not present and the words that indicate that the flag is present, we're able to improve our measures of 3 measures here: permanent, full-time, and schedule flexibility. And the biggest difference it makes for schedule flexibility, which is roughly 18% improvement to of our machine learning model to the benchmark model, which is keyword-based model. Then on the next slide, we move to the next topic, which is to show some descriptive statistics of the rise of schedule flexibility since 2014. Next slide. Just kind of to give this a high-level comparison between permanent, full-time, and schedule flexible, which we look at. So here in yellow, you see the different types of jobs that could have one or more of these 3 characteristics, where kind of if you have the permanent full-time jobs that's schedule flexible, that's a tenured academic. And then you have kind of jobs that relate to part of them. And then the most prevalent contract type is a permanent job. It's over half of the job that's posted have a permanent label. Then slightly less than half have full-time, and about 26% of the jobs advertised 2019 fall into the category of being schedule flexible. Next slide, please. And so here you have a chart over time from 2014 to 2019, and you can see that flexibility is on the rise. And then, as we discussed previously, we distinguish salaried to non-salaried flexibility. And you can see that the non-salaried flexibility has increased by more than the salaried flexibility. So the non-salaried is a more problematic flexibility that tends to be very stressful for the workers who have this type of job. The next slide, please. And then we look at kind of which occupation is most likely to have schedule flexibility. And it's more on the lower end of the wage distribution. It's like elementary jobs and workers in the service sector who tend to have a higher share of schedule flexibility. Next slide, please. And if we look at the wage distribution, as reflected previously with the occupations, and those earning the lowest hourly wage brackets, that they tend to have more schedule flexibility in their contracts. Next slide, please. And then we kind of do some sanity checks on kind of how reliable is our data. And here we show that the share of non-wage vacancies within the occupation and county, the higher the share of low-wage vacancies, the higher the share of schedule flexible and non-salary vacancies. Right? We see this positive correlation with non-salary vacancies. We do not see this relationship with salaried vacancies, where this relationship is flat, the line is flat. And similarly, on the next slide, we can see that when we look at the share of permanent vacancies by occupation county block, we can see that the more permanent vacancies there are, the less likely a job is schedule flexible and non-salaried. And again, if we look at the salaried vacancies, we do not find this relationship. So the most interesting things we observe are for these schedule flexible non-salaried jobs. The next slide, please. So then we go on to explain what drives the increase in schedule flexibility. And we look at one of the interactions in the policy pivots in the UK, which is the introduction of the minimum wage legislation. And the next slide. So the minimum wage legislation was a shock and was unexpected. Unexpected both that it went through Parliament in the speed with which it went through Parliament, and it was a substantial increase of the minimum wage, not only once, but it put the minimum wage into a schedule. So there was stepwise increases since the legislation has passed. On the next slide, next one. Okay, on this slide, you can see in the first column the minimum wage for those 25 and older. And you can see on the last row that it starts with 650, and then went up to 670, and then most recently it's at 821 pounds per hour. So there's a strong increase in the minimum wage since the legislation has passed. The next slide, please. So what we do is we do a triple diff empirical estimation, where we look at two differences. The first one is we look at exposure to the minimum wage legislation over regions. And the second one is exposure to minimum wage legislation over occupations. On the next slide, if we skip this one, just in the interest of time, moving faster, one of the findings is when we run the regression specification, but here with the kind of, share of job ads that have specific wages, we find that with the introduction of the minimum wage, as we would expect, we see a drop in the share of vacancies that have low salary, and we see an increase in the share of vacancies that have a higher vacancy, that have higher wage. And that tends to stabilize over £9, where we don't see a change in the share of their prevalence over time. Then on the next slide, we look at the results of this diff and diff regression on schedule flexibility. And you can see that with the announcement of the increase in the minimum wage, we see in parallel kind of a side effect of this policy that kind of the quality of the jobs, kind of the non-wage characteristics of the jobs deteriorate over time. And that the share of schedule flexible contracts, in particular those that are non-salaried, increase, while the share of the schedule flexible contracts that are salaried doesn't change. And we can see also that the share of schedule flexibility increases for the lower wage bins from £7 to £9 and are not significantly different for the higher wage bins. And then
1 minute, please.
Perfect. And I'll blitz through the last slides on COVID-19 if you go forward. So we show you some of the characteristics of COVID-19. So on the next slide, we'll focus on 3 metrics. So we focus on where do we have fewer jobs compared with last year. And then one area stands out of all the months, which is West Midlands, which has been hardest hit by COVID-19, and that's the biggest relative drop of job vacancies relative to all other areas. It's very persistent. On the kind of pay front, we do not see such a strong difference. We see kind of slightly lower pay, but we have the literature on wage rigidity, which kind of points us to a tendency that wages do not tend to drop much. And then the last point was on schedule flexibility. And we do see from March to April a strong increase in the prevalence of schedule flexibility. It was a temporary increase. It's only April and May which were affected. And since then it normalized. We do see kind of this margin of adjustment that firms take in order to react to the COVID-19 shock. Great, and then to sum up, there was this 4 takeaways. First one is machine learning is really important to work with a big corpus of vacancy text. That's on the last slide. And then the second one is schedule flexibility is on the rise since 2014. One of the hypotheses we investigate is the desire by employers to shift labor costs. And lastly, during COVID-19, this again has been an important margin of adjustments for the companies to introduce more schedule flexibility. Thank you very much.
Okay, thank you, Matthias. And thank you everybody for presenting. So you can show your videos now, and we have time for Q&A. So, I mean, very interesting papers, these and the sessions this morning, and it just illustrates how many people are working in the space and what kind of interesting questions you can answer, but also there's a lot of overlap. And, you know, it's interesting that, you know, to have a forum like this where people can actually present and then find out what other people are doing in the same space and interact. So I think it's a very useful kind of vehicle for that. We overran a little bit on time. It was very difficult, I know, for all of you to present very complex material, but I've asked for a little bit extra time, so we do have time for questions and answers. So as usual, what I'll do is I'll go to the Q&A. So anybody who's got questions, please do add them to the Q&A. And I'll start with Claudia Plymouth and a question for Jeisson.
Okay, you mentioned that you used ESCoE for normalizing skills, and I wonder what experience you made with this taxonomy. Was it easy to use, or did you have to supplement lots of synonyms, for example?
Yeah, this is a good question. Well, we use the ESCoE dictionary to identify skill patterns in the job vacancy. What can I tell you is my experience is identifying skills is a difficult task. The ESCoE helps a lot to identify skill patterns. Basically, in a general way, if you use a normal or a standard procedure to identify tests in the job description using the ESCoE dictionary, you may find the patterns that you are looking for, but also you will find some mistakes, or the algorithm may fail in some cases. So what we are doing right now is improving that algorithm by adding more steps or parsing the data. And we have somehow minimized that noise that we get from the data. But so far, and I think all people that have worked with the ESCoE dictionaries can say that at least with the ESCoE data and the vacancy data, you will identify skill patterns. I don't dare to say that we are able to identify the exact number of skills for a certain occupation. We will, so far, are identifying skill patterns by occupational groups. And this is another important aspect, which every time that we produce indicators at the skill level, we should look at the occupations and skills are related, or if not, if it allow us to evaluate if it's because it's a new skill or because basically the algorithm is not working very well in that specific observation.
Thank you. I have a question from Sanjeev. Sanjeev, you haven't said who you're asking the question of, so please.
Thanks, Mary. I would say well done to the presenters, some really good analysis, and also a lot of linking of very large data sets, and some of the data sets are common data sets. So in a sense, I've seen a lot of the stuff in various guises, and I compliment you. But I was going to try to stretch you in the further analysis that you could do, and obviously with the policy link in mind. So the first one is, based on the data sets you've got and the linking you've been able to do, I want to turn it around. Can you link the vacancy to the company, whether it's a small company, medium-sized company, or a large company, by region, by industry, as time series? Because those changes and trends will obviously inform policy. If certain types of businesses, whether they're small or large, certain types of industries and regions are building up, in a sense, the stock of vacancies in particular professions, that's really informative. And then the second one is, obviously COVID has going to affect us in many, many, many ways. But one of many ways is the home working dimension. Many companies now have realized they don't have to have all their staff in big offices, small offices, etc. They can do home working, teleworking, etc. But it's not just within the UK now. You know, I've seen job vacancies, and some have come to me, luckily enough, where people can have specialisms. You're at home and you can work anywhere around the world, not just a region within the UK. You've got the specialism, the trade, and it's really good. So in a sense, the traditional workplace residence challenge is now become even more, because your workplace is your residence. Your workplace and residence may not even be in the country where the company is that's employing you. So given your data sets are very recent, up to 19 and 20, it'd be very interesting if some of these sort of nuances can be picked up. I don't know what you think can and can't be done on my two proposals. Thank you, Mary.
Okay, anybody want to, Bledi, you want to?
I can take that. I mean, in terms of the company level, I think the short answer is yes. I mean, there is a company information in almost all of the data, either our data or other providers, and you can merge from from that company level to sort of external data set in order to identify this is small company, medium company, large company, and potentially other type of companies with this are startups. So the short answer is yes, you can do a company and regional analysis. I think the longer answer is yes, but you need to be very careful, especially when it comes to time series, right? So time series analysis have shown at least, you know, that they work well when you do it at national level, at the regional level. But a reason for that is also that we have data to benchmark against, right? There's a publicly available data. We can see, you know, how our analysis behaves, and if not, you know, you can adjust accordingly in some ways. But a lot of times with companies, such benchmarks don't exist. So, you know, so the evolution of the companies and, you know, how they behave is a little bit of a black box. So you're really going into blind there. So yes, the analysis can be done, but especially when it comes at a company level, it's a lot more complicated to know if you're actually on the right path, because there's no appropriate benchmark. To my knowledge, there's no, you know, publicly available data that goes beyond, you know, the publicly traded companies that you can actually see what is the evolution of that. While for, you know, overall national, you know, hires or job postings, that there are official statistics that you can benchmark against. In regard to your work from home, right? So the work from home is obviously something, is an information that is contained there. There's people that actually have utilized that information to do some analysis. I know Eric Bjornson, for example, has a recent paper, you know, that utilized our data, that, you know, doing some of that work. I think what you're alluding to is a little bit more like not the work from home, or actually the work from anywhere. I haven't seen that as much being picked up, and I don't expect it to be as widespread yet. But I think, you know, we've all heard about it, that, you know, people moving from France to Sicily and working from them because, you know, nice weather and low rent. But, you know, looking at the data, I don't think that is something that is a large trend so far. Probably will be in the next you know, months or years to come. But, you know, the short answer is that yes, that's type of information that you could extract from the data if it is there. And the work from home is fairly straightforward to do.
Can I add a comment?
Yes, Matthias, please. Yeah.
On the second point, in work from home, I agree with Sanjay that this is truly potentially transformative. If we exit the COVID-19 with the mass vaccination of the populations, if companies choose to maintain a substantial share of the workforce that works from home, that will dramatically change not only the commercial real estate market, but a number of the salary premiums that we observe in the economy. So at the moment, we observe that in counties that tend to export goods or produce goods for export instead of for domestic markets, these areas tend to have a higher real income. So for the same task and skill requirements, they tend to pay the worker more. There tends to be this agglomeration effects around cities. And as kind of work from home becomes available, there's a serious question of whether these higher real incomes in large export-focused cities will be able to be maintained. And also, as we kind of move to the international hiring, then the competitiveness of countries suddenly hinges, of the workers within countries, suddenly hinges much stronger on the exchange rate. In that kind of exchange rate will determine how expensive foreign workers are. And if you are an employer in the UK, then the exchange rate works in the opposite direction, is that if the pound depreciates, you suddenly have to pay much more for your foreign workforce. So then suddenly, as foreign exchanges fluctuate so much, you suddenly have kind of a very volatile wage bill for companies, much more volatile as it was before COVID-19, when more hiring was local. So that could have really dramatic consequences of the structure of the economy going forward. And it's very interesting to observe this closely.
There's another question for you, Matthias, from Maria Grazia.
Yes, thanks a lot. So actually, I find the work on the flexibility very interesting, because that's a question that we all have, and we went back also now in this discussion. Although I think that we all learned that we went from 0 to 100 in the case of those that never worked from home before. And now we are appreciating the value also being, not always perhaps, but at times in the office and rushing out of home anyway. But you were talking about this flexibility and how, and I think for a policy reason, that would be very important. If and whether you can distinguish what is the effect of flexibility coming from changing in patterns of, say, cost reduction and things like those that you have documented in your study, as compared to what has been the flexibility to some extent imposed by furlough schemes, whereby there was a matching covered by the country insofar as workers were working at least a certain number of hours. And I think that's extremely important, because otherwise we cannot really claim that this pandemic is accelerating the need for flexibility, because at the end of the day, it is something that is mechanically induced by the schemes that are keeping companies alive at this moment. Thank you.
That's an excellent point, Maria Grazia, and that's absolutely right. I mean, one of the things we want to look into next is kind of the distribution of power of who determines the schedule, right? Is that schedule flexibility can be much more welcomed by the worker if the worker determines the schedule, and much less welcome if the employer determines the schedule. So what we have done so far, like the academic paper excludes COVID-19. COVID-19 was just kind of a application of what we've developed to the most recent crisis. That wouldn't be part of the academic paper. In the academic paper, we focus kind of on the lower end of the wage distribution, where kind of the employer-enforced schedule flexibility is much more common. Then at the higher end of the wage distribution, such as kind of like the jobs you and I would have, we would have some schedule flexibility, but it's kind of working in our favor. The other one is to point at the literature that surveys that use natural experiments to elicit the willingness to pay of workers for schedule flexibility. And the papers that have been published on this literature point to a very low price. So most of the workers do not value schedule flexibility, do not want schedule flexibility, are not willing to pay for schedule flexibility. A very small fraction, small percentage fraction of the workforce is willing to pay for it, but also kind of an insubstantial amount of the total salary.
Thank you. We have another question from for Bledi from Jorgi from ONS.
We can't hear you, but I can read the question.
I don't know if he's still there.
Yes, we could hear you.
He is unmuted, so I don't know if we can't hear him. Maybe you could read the question, Mary?
Yeah, it's quite a long question. So, so he says, skill adjacency concept really interesting, but is there not potentially a bias on more technical skill-rich jobs? The concept for helping people's mobility may be more appropriate for those in jobs more likely to be unemployed, which would come from the lower skills jobs. So what can you do where the skills are not very well covered in job adverts or just implicit taken for granted?
I actually think that's a very excellent question, and it's something we've had to deal with. I think the idea is we've had two approaches to that. One is actually to augment this, and it is true that the information that you have for higher end or better paying jobs is a lot better in online vacancies than that is in the lower end. And for that reason, when we did the different reports with the World Economic Forum, we actually augmented essentially the vector of skills that comes from online job postings with the on-net data. And essentially this creates a sort of more balance, because there are some occupations, not all of them, that could be very poor in online jobs. For example, my favorite example is truck drivers. In the majority of the cases, they say, I only want you to have a driving license. And then good luck with figuring out, what is the next occupation for a truck driver just based on that. So in those cases, you do need sort of augmented vector of skills, and you can add one to another, and then you can create the similarity of different ones. The second approach, which essentially we used in this one, is actually sort of the opposite. Is to actually constrain both the vector size and the set of the different options, because we were focusing on sort of lower to middle paying type of jobs, and then you can constrain the different skills that you're looking. Again, we have more than 80,000 skills. If you create a vector on all of those, you're going to get a very imbalanced sort of panel of skills. And when you do the similarity across all of the skills, you're going to get better matches with the high paying skills. So in order to do it with all, you can do it with a smaller set, and then you also have to do it with a smaller set of occupation. What you're essentially doing is that you're controlling the set of the different transitions, using the skill information and the occupation information that you But yeah, the short answer is that that type of bias is possible to happen, and yes, you need to do it carefully. But the other thing is that, you know, this type of approach, and especially the similarity thing, only gives you one part of the answer. It tells you what is possible, right? It tells you what is possible in terms of the different transitions. It doesn't necessarily tell you what is feasible or what is desirable, right? In terms of feasibility, right, you also need to look at other stuff, like geography is another dimension, right? It could be that, you know, it is possible to move from occupation A to occupation B, but if occupation A is mostly, you know, down, and you know, all of the other, you know, occupation B is mostly Northern Ireland, for example, you know, those transitions are maybe not feasible, right? And the other thing that, you know, a lot of this, you know, that the similarity doesn't take into account is the desirability of this transition. Again, it could be possible to move from one occupation to another, but if this, you know, second occupation is significantly smaller, right, this is a niche occupation, right, then you don't want to move people there. So I think you need to take into account not only the possibility, but also the desirability and the feasibility of the transitions, and you can use additional metadata to do that.
Thank you very much for the answers. I'm afraid we're out of time again. So thank you again. Thanks everyone for very stimulating presentations. And we'll see hopefully everybody back at the panel session at 3:30. Thank you. Bye.